Here I have the log of a times b times c. All right. Notice that my argument is a product. So which law am I going to use? The product law. Now, recall that log base a of p times q is equal to log base a of p plus log base a of q. All right. That simply means that to expand the log of a times b times c, that's simply going to be the log of a plus the log of b plus the log of c. All right, let's move on. Here I have the log of a divided by bc. And if you notice here that my argument is actually a fraction, right? With a numerator and a denominator. So which law can I apply? I can apply the quotient law of logs, right? Which says that log base a of p divided by q is equal to log base a of p minus log base a of q, right? So if I'm going to expand this logarithm using my quotient law, I'm going to have log of a minus the log of bc. And now I can expand this logarithm using the product law because my argument here is a product and that product is bc, right? So I'm going to have log of a minus into the log of b plus the log of c. Now I can distribute the minus. It's going to give me the log of a minus the log of b minus the log of c. Okay, so let's move on now. All right. So now here, the first thing you should notice is that my argument is being raised to a power, right? So which law can I apply first? I can apply the power law first, right? Which says that log base a of p raised to the power of b is equal to b times log base a of p, right? Simply move that b and put it in front there. All right. So my first step, I'm going to take this 2 and put it in front here using my power law. So I'm going to have 2 times the log of a cubed times b. And now which law can I apply to expand this logarithm? I can use the product law, right? So it's going to give me 2 into the log of a cubed plus the log of b. All right, and if you notice here that for this logarithm, I can use the power law to bring this 3 down. That's going to give me 2 into 3 times the log of a plus the log of b. So if I distribute the 2, I'm going to get 6 times the log of a plus 2 times the log of b. Okay, so let's move on to the next question. Here I have to expand log base 6 of x minus 1 over x to the 5th power. All right? Now the first law I will be able to apply is the quotient law. All right? So I'm going to get log base 6 of x minus 1 minus log base 6 of x to the 5th power. All right? Now I can use my power law to bring this 5 out of the argument and bring it in front there. That's going to give me log base 6 of x minus 1 minus 5 times log base 6 of x. All right. Let's move on to the next one. Here I have to expand the ln of the 8th root of e times y. Now, there's another way for me to express the 8th root of e times y. Remember our laws of indices, right? Let me go to the side here. The 8th root of e times y is also equal to e times y all raised to what power? 1/8. Right? So therefore, the ln of the 8th root of e times y is also the same as the ln of e times y raised to the power of 1/8. And if you can remember my power law, I can bring this 1/8 in front here. Right? So that's going to give me 1/8 times the ln of e times y. And now which law can I apply? I can now apply the product law. Right? That's going to be equal to 1/8 into the ln of e plus the ln of y. And what is the ln of e going to be? The ln of e is going to be 1. Remember from our previous video. I can distribute the 1/8, which is going to give me 1 upon 8 plus 1 upon 8 times the ln of y. All right, let's look at another problem. Here I have the log of the cube root of m over syk. Remember that I can express the cube root of m over syk as m over syk all raised to the power of 1/3. Right? So it simply means that this is the same as the log of m over syk all raised to the power of 1/3. So now I can bring down this 1/3 here using the power law. That's going to give me 1/3 times the log of m over syk. Okay. Now looking at my argument, I have a fraction. So the first law I should apply is my quotient law, right? So that's going to be the log of m minus the log of syk, right? And down here, I can apply the product law. So that's going to give me, let me change my bracket to something else. That's going to give me the log of s plus the log of y plus the log of k. Now I'm going to distribute the minus. So I'm going to get 1/3 into the log of m minus the log of s minus the log of y minus the log of k. And we can now distribute the 1/3. Distribute the 1/3. So this is going to give me 1/3 times the log of m minus 1/3 times the log of s minus 1/3 times the log of y minus 1/3 times the log of k. This one looks very complicated, but it's not. If you look at the argument, first thing you should notice is that it's a fraction, right? With a numerator and a denominator. And the first law I should apply when my argument is a fraction is a quotient law. So I'm going to get log base 3 of 18 into x plus 2 all raised to the second power minus log base 3 of x minus 2 all raised to the third power times x plus 5 all raised to the second power. And this entire product is my argument. All right, same thing here. Okay, now I can't just go ahead and apply the power law and bring this 2 down here. No, because I'm not raising my entire argument to the power of 2. I'm just raising a part of the argument, that being x plus 2 to the power of 2. Right? So the first thing I have to do is apply my product law to break up the 18 and the x plus 2. All raised to the power of 2, right? That's going to be equal to log base 3 of 18 plus log base 3 of x plus 2 raised to the second power. Now, down here, which law can I apply? I can apply the product law. Right, so that's going to be minus into log base 3 of x minus 2 raised to the third power plus log base 3 of x plus 5 raised to the second power. All right. Now I can apply my power law here to bring down this 2. I can apply my power law here to bring down this 3. And a power law here to bring down this 2 here. All right, so that's going to be equal to log base 3 of 18 plus 2 times log base 3 of x plus 2 minus into 3 times log base 3 of x minus 2 plus 2 times log base 3 of x plus 5. I can distribute this minus, distribute. That's going to give me log base 3 of 18 plus 2 times log base 3 of x plus 2. That's a 3 there. Minus 3 times log base 3 of x minus 2. Minus 2 times log base 3 of x plus 5. And that's how we expand. So let's say we're asked to state each of the following formulae in terms of logarithms, each with a single symbol. Well, this is essentially asking you to expand your logs, right? Because all you're going to have to do is log both sides of this equation. So I'm going to have the log of A is equal to the log of L times B. And now I'm going to apply my product rule to expand this logarithm. So log of A is going to be equal to the log of L plus the log of B. So now I have the equation y is equal to ax squared. Now we're going to log both sides. Log of y is equal to the log of ax squared. Right? And now we have to apply the product law. Reason is because only the x is being raised to the power of 2, not the entire argument. Right? So I'm going to break up this logarithm using the product law. So it's going to give me the log of a plus the log of x squared. Now I can use the power law to bring this 2 out of the argument. So I'm going to have the log of a plus 2 times the log of x. That's what log y is equal to. Alright, I have another equation. S is equal to a half of ABC. Again, I log both sides. I'm going to have the log of S is equal to the log of a half ABC. And which law can I apply over here? I can apply the product law. So I'm going to have the log of S is equal to the log of a half plus the log of A plus the log of B plus the log of C. All right, that one was quite simple. All right. What if I have S is equal to A divided by PR? Again, I log both sides. I'm going to have the log of S is equal to the log of A over PR. And now I'm going to use which law? The quotient law, right? This is going to give me log of A minus the log of PR. And now I can expand this logarithm using the product law. First, let me write back my left-hand side. All right, so that's going to be the log of A minus the log, well, it should be minus into the log of P plus the log of R. Now I can distribute this minus, all right? So this is going to give me log S is equal to log of A minus log of P minus the log of R. Okay. So I have another equation. Again, I log both sides. I have the log of A is equal to the log of 2 pi r squared times h. That is the argument. I can apply the product law. The log of A is equal to the log of 2 plus the log of pi plus the log of r squared plus the log of h. Alright, so log of A is going to be equal to, remember I can take this 2 out of the argument to put in front of using the product law. So now I'm going to have log 2 plus log pi plus 2 times log r plus the log of h. Okay, so what if you're asked to state each of the following logarithmic formulae as a formula without logarithms? Essentially what they want you to do is to ensure that both sides of my equation only have a single log, and then I can use the fact that once the bases of my logarithms are the same, for a logarithmic equation, then the arguments on both sides of the equation must be equal, right? Now, on my right-hand side, I have multiple logs. I want to bring them together. So I'm going to essentially use the product law in reverse. So now I'm going to have the log of A is equal to, use my product law in reverse, I'm going to bring everybody here together, right? So I'm going to have the log of pi r t, right? Now, again, it's understood that my base is 10, right? So the logs on both sides of the equation have the same base. And if that is the case, in order for the equation to be true, the arguments must be equal. So it means that A is equal to pi r t. All right, let's move on to another one. Now I have the log of w is equal to the log of a half plus the log of m plus 2 times the log of v. All right, objective remains the same. We have to express the right-hand side as a single logarithm. So we're going to use our product law and our power law in reverse. Because look, I can't just integrate this v into my argument just yet. I have to get rid of this 2 in front here and put it into the argument, right? That 2 is blocking me from bringing everybody together. So I'm going to have the log of a half plus the log of m plus, using the power law in reverse, the log of v squared, right? So now I can apply my product law to bring everybody together. So I'm going to have the log of w is equal to the log of a half mv squared, right? And again, logarithms with the same base, therefore arguments must be equal. So w is equal to a half mv squared. And this should be a familiar formula. Now let's look at another one. I have the log of e is equal to the log of m plus 2 times the log of c. Again, I want my right-hand side to be a single log. But first, I'm going to apply my power law in reverse to get rid of this 2 in front here, bring it into the argument. So I'm going to have log of m plus the log of c squared, right? That's what the log of e is going to be equal to. Now the log of e is therefore equal to, using my product law in reverse, I'm going to have the log of mc squared. Again, bases are the same, so therefore the arguments must be equal. So E is going to be equal to mc squared. This should be another familiar formula. Now here I have another one. Objective remains the same. I'm going to have the log of r is equal to, I'm going to bring the log of m and the log of v together using my product law in reverse. Alright, so I'm going to have the log of mv. Now what I'm going to do, let me just write this out first. Log of e. Now what I'm going to do, I'm going to group the log of b and minus the log of e together, and I'm going to factor out the minus, right? So I'm going to have the log of r is equal to the log of mv minus into the log of b plus the log of e. And now which law can I apply here? I can apply my product law in reverse now. Right, so it's going to give me the log of r is equal to the log of mv minus into the log of b times e. Now I can apply which law? I can apply my quotient law in reverse. So now I'm going to have the log of r is equal to the log of mv over be. And now I have a log with the same base, so therefore arguments must be equal. So r is equal to mv divided by be. First thing we're going to do is bring this half into the argument. And this is the log of z, by the way. Alright, so I'm going to have the log of t is equal to the log of 2 plus the log of pi minus the log of z raised to the power of a half. So now the log of t is going to be equal to, use the product law here, it's going to be the log of 2 times pi minus the log of z to the power of half. And which law can I apply here? I can apply the quotient law in reverse, right? So the log of t is going to be equal to the log of 2 pi divided by z raised to the power of a half, right? And z raised to the power of a half would be the same as square root of z. Remember, laws of indices. So I'm going to have the log of 2 pi divided by the square root of z. Okay, now here I'm asked to simplify this logarithmic expression. Okay, so let's go right ahead. The first thing I could do is apply my power law to bring the cos x out of the argument, right? So I'm going to have cos x times the ln of e. And the ln of e, what did we say the ln of e was? The ln of e was 1. Right? So therefore means that the ln of e to the power of cos x is equal to cos x.